All right, today's video is on lesson 4.7, triangles and coordinate proofs. And so when we look at writing coordinate proofs for proving different shapes, in this case triangles, it is more algebraic in nature because we're using numbers versus just our theorems and just general statements. So I think in this particular lesson, it's a little bit easier. So first, what is a coordinate proof? A coordinate proof is when we place a geometric shape on a coordinate plane and use the distance or midpoint formulas, theorems, or postulates to prove statements. So again, we're going to take our geometric shape, a triangle, parallelogram, whatever it might be, and we're going to lay it on a coordinate plane. So if we use a coordinate plane, okay, we have the ordered pair 0, 0, which is the origin. Well, computing with zeros if for both x and y really makes things quite easy. So we always want to try to put one of our vertices of whatever shape it is someplace on the origin. And then, in my opinion, it's easier to use positive numbers. So I'm going to place as much of a shape as possible in the first quadrant. Then that way I don't have to worry about negatives and if x is negative or y is negative or both are negative. This way, all my points will be positive. So whenever possible, you want to try to get that shape into the first quadrant. So let's look at example number 1. It says that a right triangle has legs of 2.5 and 6. And we want to place that triangle in a coordinate plane, label the vertices, and find the length of the hypotenuse. So this is just, can you put it onto a coordinate plane and use the information? So on a piece of graph paper, put the vertex of the right triangle on the origin. Now, we want to make sure that that right angle is on that origin as well, because then my x-axis and my y-axis will act as the legs of that right triangle. And so it's really easy then to draw a line segment that's 2.5 as well as another line segment that's 6. And so on the y-axis, you can make your 2.5 line segment, and then on the x-axis, make the 6, or you can do them the other way around. It really doesn't matter. And then once we do that, we're going to label the vertices and find the length of the hypotenuse. So we're going to use the distance formula in the two ordered pairs, whether they're 0, 2.5, and 6, 0, or the other way around. And we're going to use those to find the distance of the hypotenuse and use the distance formula. Remember back to what the distance formula is. Something with a square root and adding some coordinates together and squaring them. So I'll let you refer back to your book to get that information, but use that distance formula. Then in example number 2, I already drew it on the coordinate plane for you. And in this particular problem, I know that triangle triangle FRD is congruent to triangle RFO. We need to find the coordinates of point S if S is the midpoint of FR. So I've drawn in the coordinates, and so if you note, please, that point F is at 0, 10, so each of my lines is worth 2, so I've counted by 2. And same with point R, it's 8 lines over, and so the ordered pair is 16, 0. So use the midpoint formula to find where point S is if it's halfway or at the midpoint or bisects line FR. Again, I think you should be able to do that. This next problem really isn't too tricky. A lot of people get a little bit nervous when they see problems like this, and we'll look at a number of these types of problems. I want to know, what is the coordinate of point J? Well, again, I've put one of the vertices on the origin, so the ordered pair there is 0, 0. So if I look, I have a parallelogram. That should be pretty easy to identify because my x-axis is parallel to this line LJ here. And then if we look at the slope of LO and JH, we notice that those slopes are the same as well. So those two are parallel. So then if I'm trying to find point J, I know I have to go over A units to get to point H. how many more units do I have to get over to get to point J? Well, I go over A units here, and each of these, the two of them together are B. And I know that because I have to go over B units to go up to point L. So point J on the x-axis is A plus B units over, because these two units are the same as these two units up here, and so I have to go over to get to point L, I have to go over B units. So point J, the x coordinate is A plus B, and then the y coordinate is pretty easy because to go from here up is the same as to go from here up to point L, which was C units high. So the coordinates of point J are going to be, for my x coordinate, A plus B, and for my y coordinate, it's just going to be point C, or the value C. So try the other two problems and let me know if you have any questions tomorrow. We'll go over this in more detail. Have a good night.